Hey everyone, this is Carter Wetzel here, one of the researchers at Shade Protocol, and today we're going to be talking about ShadeSwap and SilkSwap. SilkSwap is a new invariant that's focused on stablecoins, and one of the key developers here today, Alex Harker, was kind enough to hop on and kind of talk about what it is, why it's important, how it works. So Alex, thanks for coming on. Tell us a little bit just about your journey in crypto so far and how you got to where you are today.
Yeah, I got into crypto pretty recently when I joined Secure Secrets, Shade Protocol. I got into it because I was friends with Carter actually from way back, and he asked me if I was interested in working on this vision that he had. So I hopped on, kind of took a crash course in crypto and picked it up pretty quick.
100%. So, we kind of put you on the stable swap project right from the get-go. So walk us through what is SilkSwap? What is it trying to accomplish? And kind of what makes it unique?
Yeah, so SilkSwap is a stable swap, it's an AMM that is designed for swapping stable coins with each other. It takes advantage of the fact that they have predictable prices to reduce the amount of price impact or slippage that's needed. SilkSwap is a unique stable swap in the sense that you have asymmetrical control over both sides of the curve, which we'll be getting into.
Yeah, it's super interesting because for the most part, we've seen perfectly symmetrical AMM curves, but as time has kind of gone on and decentralized finance has evolved, there's situations where having asymmetric curves is actually helpful, mostly because there's situations where order flow is asymmetric, and like as a market maker, you want to have a curve that can best represent order flow. And there's also security tied to being able to have control over the different tails. So maybe Alex, you want to hop into the white paper, walk us through some of the parameters and walk us through some of the math behind what's going on here.
Yeah, for sure. Something to pull it up. All right, so this is the white paper. It's quite detailed. I'm not going to go through everything here. It's publicly released, so it should be available. But I'm just going to highlight some of the key points. So there's quite a few parameters that we can manually set to control the shape of the curve. And when we're talking about a curve, let me just start with that. All AMMs, the point of an AMM is to automatically set a price based on pool sizes, a price that you can trade assets at. And you can graph the set of allowed pool sizes as a curve. So this is an example of one of those graphs. On the x-axis, we have the size of one of the pools. On the y-axis, the size of the other pool. For a constant product curve, which is the orange line, the product of the x pool times the y pool has to always be equal to a constant. So that gives us this line. And what this line is showing is essentially the set of allowed pool sizes. So this is saying if you have 3,000 of token X in your pool, you have to have like 400 or 500 of token Y, or else you're off the curve, which is a situation that you should never be in. So a constant product curve will look like this. And that is kind of the standard default AMM approach. A constant sum curve, which is not something that's actually practically used, as far as I'm aware, it would look like this. And this is a curve that's saying there is no slippage, no price impact. You can just swap one token directly for the other at the defined price, no matter what the pool is. So the issue with a curve like this is that you could entirely swap out one token for the other and drain one of the pools. And that's a problem. And so to solve that problem, people have invented the constant product curve, which essentially goes off to infinity on both sides, so that as you try to drain one of the pools, that token becomes more and more expensive. And that's done intentionally by introducing price impact, by introducing slippage. Price impact is the correct term for it. Slippage is the colloquial name. You introduce that to disincentivize trading when the pool is unbalanced.
I'm gonna just jump in here with the question. So it's really interesting from a trader's standpoint. A linear trade is ideal, right? I want like no slippage. I don't want any price impact. I want just like as much as I can on my trade. I don't really care, right? But ultimately, these protections are put into place to protect liquidity providers. So what's the so can you walk us through like price impact as a protection? Is that purely for liquidity providers? And yeah, I would just if you could dive into more of that protection and what that represents.
Yeah, so price impact is mostly for liquidity providers. What it is essentially a slight lack of return on the trade, right? So if you have two assets in a pool together that should be the same value, and you put in, let's say, 5 of one asset as a trade, you'd think you'd get 5 of the other asset out. Price impact will say, I'm going to give you slightly less than 5 because it's essentially a fee that you're paying to the pools or to the LP providers to cover the cost of changing the ratio of the pool, essentially. And that fee gets increasingly large as the pool becomes unbalanced in one direction or the other. And when I say unbalanced, I mean the pool's price, the trading price of that pool becomes out of line with the market price for those assets.
Perfect. That's super interesting. Go ahead if you want to jump into the next one or can continue on. That was just one of my questions I had.
Yeah. So what a stable swap does is it says price impact is a good thing because it protects LP providers. But it's also, from a trading perspective, a negative, right? It'll turn traders away if the price impact is too extreme. So a stable swap tries to find a happy medium between the constant product curve and the constant sum curve. So this is a graph of, it's the same thing as before with constant product in orange, constant sum in blue, with also a stable swap curve in between. And this is the SilkSwap curve. So you can see that the SilkSwap curve tracks along the constant sum curve for a while before it begins to shoot up to infinity. So what that means is, as long as the pool is near the target price, you will be getting very little price impact on your trades as a trader. But LP providers are still protected because as the pool becomes unbalanced in one direction or the other, the price will still increase, so the pool cannot be drained. And so there's quite a number of parameters that we can control to change the shape of this curve. You can see these listed at the top of these graphs in the white paper. We can ignore P for now. D is just the invariant of the curve. So in a constant product curve, what that would mean is you have something like X times Y equals K, or K is a constant. That constant is called the invariant. And that's something that's just calculated from the pool sizes and shouldn't change as you move along the curve. But the parameters that matter most are A, gamma 1, and gamma 2. These are the ones that we have manual control of and that change the shape of the curve. Parameter A essentially determines how wide of a section of the curve maps onto constant sum closely. So a small parameter A is shown in this left graph here. And that's, so you have kind of a narrow section of the green line, the SilkSwap invariant, that's similar to the constant sum. But if you look at this right graph, which is the same thing, except parameter A has been increased, you can see that the section of the green line that maps close to constant sum, the blue line, is much wider. So what that means is there's a wider range of allowed pool sizes which have very low price impact before the price begins shooting up from price impact. So parameter A lets us control the range in which you get very low price impact. The other important parameters are gamma 1 and gamma 2. And these control how quickly the shoot up to infinity happens on each side. So if we look at these bottom two graphs, these are designed to show differences in gamma. So on this bottom left graph, we have gamma 1 equals 8 and gamma 2 equals 2. So gamma 1 will control the left side of the curve. Gamma 2 will control the right side of the curve. A high gamma value means that the curve will quickly go off to infinity, whereas a low value means that it takes its time. So you can see on this left graph, we have gamma 1 is higher than gamma 2. So the left side of the curve goes up much faster than the right side of the curve does. And on the bottom right graph, gamma 1 is 2, gamma 2 is 8. Those are just flipped. And so you can see that the left side of the curve takes its time before it goes off to infinity, and the right side only does so. It does so much quicker.
One question I have is, so obviously gamma 1 and gamma 2, they're supposed to be kind of disconnected from each other, but they still impact each other because they're all part of the same curve, right? So it's not perfectly independent. If gamma 1 is like crazy high at the end of the day, that will like walk me through that relationship, the relationship between gamma 1 and gamma 2, I guess.
Yeah, so when you're looking at a graph like this, both parameters are in play at the same time to define the shape of the curve, right? So any pool size that is to the left of equilibrium, which to translate that into the actual pool sizes, that's basically saying when token Y is overrepresented compared to the market price, will be controlled by gamma 1. When token X is overrepresented, that part of the curve will be controlled by gamma 2. And so both parameters define the shape of the curve. But at any given moment, when a trade goes through, only one value for gamma will be used. So what will happen in the code is it will look at the current tokens, see which one of them is overrepresented, if either is, and it will choose the appropriate gamma.
Fascinating. Well, that answers my question there. How, like, when you're coming up with parameters, how do you settle on optimal parameters? Like in the real world, we'd love for there to be some sort of linear optimization to be like, this is the perfect config file for this. But in your mind, Alex, what is it? What does optimal curve behavior look like with respect to SilkSwap?
Yeah, there was a good amount of testing that went into choosing some of the default parameters, let's say. There's quite a few considerations. So the first obvious consideration is what shape of the curve do we want that will give users, traders, a good price trade. You know, they want low price impact, but that still protects liquidity providers. So that's the first consideration. The second consideration is practical limits of the code. Gamma is used as an exponent, as you can see if you read the paper, which creates large values quickly and can lead to overflows and other mathematical issues if you're not careful with how you set those parameters. And so we spent hours testing different combinations of these parameters to see what worked and what doesn't. And to actually like dive into the actual nuance of all of that would be a long process. But let's just say these parameters were carefully chosen.
Fair enough. Fair enough. Well, if you want to keep scrolling through the white paper here and pointing out anything else that you think is important, feel free to do so.
Yeah, for sure. So just as a summary of the white paper, you can see graphs of how the price of one asset will change as you increase the size of the pools relative to what you would expect. So stable swaps and SilkSwap in particular have this idea of an equilibrium point or a target price. And that's something that constant product curves usually do not have. And so we can define a equilibrium point or the constant price to match kind of the expected value of an asset. So if we're trading $2 stable coins, they would both have $1 as the expected price, which would mean the ratio that we expect them to have in the pools is around 1-to-1. And what you can do when you define a price like that is you can set up a curve where trades will become profitable if they move you towards the equilibrium point, but they'll be unprofitable if they move you away. So if you have two stable coins that are both at $1 and one of them is way overrepresented, you can actually profit by trading out that stable coin to bring the pools as a whole back to the target ratio. And that is an intentional design of a stable swap. It's one of the main benefits that we have. And so you can look at these graphs and see kind of how the price of an asset would change as you move towards or away from an equilibrium point. Those can be quite interesting. I won't get into all of the math here. These are the results of some of the tests that we've done. I won't get into all the details of what these tests represent right now, but basically, there's some complicated functions that need to be solved to generate a trade result. And this is how long those computations take given different settings. Yeah, so I think most of this white paper is designed for people who want to do a deep dive. Not a lot of details I would share at the moment.
Sure. How much, one of the questions out there is obviously a lot of inspiration was taken from Curve. So I'm just curious, Alex, from your perspective, when you compare Curve to SilkSwap for like the average person, what would you say the difference is?
Yeah, so I think the unique thing with SilkSwap is that we have independent control of both sides of the curve. What that allows us to do is essentially say that if one token becomes overrepresented, we quickly want to increase the price impact for trades. Whereas if the other token was underrepresented or overrepresented, we can leave the price impact low or medium, or as the curve would say. And that allows us to do some cool things, which I won't get into at the moment. I think that those will be announced in the future.
Yep.
But it's that asymmetrical control of both sides of the curve that's unique.
So when you think of all this work that's been put into SilkSwap and the amount of flexibility that exists there, what do you think the future is for SilkSwap in terms of if you could add more flexibility to it? Is there like, yeah, I guess what would the future research look like in your opinion? Stuff that you start to think about of like, what if we did this? What if this is possible? Have you thought about what that could look like at all?
Yeah, I think next on the list would be multi-pools. If we can pull that off, it would be huge. At the moment, the math has not been expanded to support multi-pools. And I think that there's some issues which would need to be resolved with some more research there. But I think that would be a cool next step.
And do you think it's possible? Because I know the hardest component of when you're trying to pull off something asymmetrical, but you exit the realm of two-dimensional and you get into the world of three-dimensional, things get really wonky really quick. So I'm curious, maybe if you could describe to our viewers what that what that looks like, what that problem is.
I can try. I feel like this is starting to get to the edges of what I understand too. But yeah, if you draw a two-dimensional graph, it's easy to make it asymmetrical. If you draw a three-dimensional graph, is it asymmetrical in 2 dimensions? Like, how do you define asymmetry in 3 dimensions? It's kind of the question that we have to ask and solve. So it's exciting. As far as whether it's possible, I think time will tell.
Yeah. Well, that's awesome. I'm trying to think. Any other questions. I guess from your perspective, how have you grown as a developer and like in terms of building out the stable swap? Maybe walk us through that journey, from just like start to finish. Maybe that's what we can kind of close with, is a reflection on that journey of growth and what that's leading to in the next couple months.
For sure. Yeah, when I picked up this project, a lot of the math had already been figured out by the researcher, and I was completely lost trying to approach it. He had like a Python notebook with some test code. We had a few meetings where he explained some of the stuff to me, but it was just like a wall of information that felt like I was just drowning under. I had to try to understand. I feel like anybody who tries to read this white paper now might be in a similar position. But there was definitely growth as I started to actually understand the math, figure out what was going on. At the same time, I was also new to crypto. I was figuring out like, what is an AMM? What is the role of a stable swap? Why do people want stable swaps? And so lots of pieces started clicking in those first few months of diving into this project, which was super exciting for me.
Yeah. As we get closer to it being live in production, is that a scary feeling, an exciting feeling? I have to imagine there's some mixed emotions because this is like the very, you have mathematics and you have physics, right? And there's like one of them is very pure and one of them becomes or engineering. Maybe mathematics and engineering is a better example, but this is something that's like something mathematical but is now being implemented that can be played around with in the world, and there's risk tied to that. So is there mixed emotions as we get close to launch?
I think, as with anything important, there's nervousness and excitement. Yeah, I mean, I feel like as the person who built the stable swap, I understand the risks better than anybody, and that's how it is. And there's obviously nerves that come along with that, but I'm confident. Like, we've put in hours and hours of research and work to get this to where it is, and I'm just ready to see it used.
There's a Mars rover documentary that came out recently. That was about I'm blanking on the name of the two rovers, but they were essentially given, I think it was 2 years to build them and get ready for launch. And what you said kind of resonates with what I heard there, which is like at some point, like you've thought about it as much as humanly possible, and at some point you have to spread your wings and fly and go for it. And like these are experiments at the end of the day, but at some point it's like you got to go and put it out in the wild and see if it stands the test of time, which takes, I think, everyday folks that use crypto projects, they might underestimate how much courage it takes for a developer to put something like that out there with like kind of the stamp of approval that like I think this is safe to the best of my ability. Like there's risks, but like I still think it's worth putting it out there. So I think it's a very courageous thing.
Yeah, I mean, I agree. I think that is a very similar situation. That exactly describes how I'm feeling.
Yeah. Well, thank you, Alex, for your time walking through the AMM. I know the community will appreciate kind of that walkthrough, some of the math. And as you said, the specific curve is how we're going to be using them on the app side. More of that will be coming out in the near future. But super appreciate your time. Good luck as we approach mainnet launch, and hope you have a wonderful day.
Yeah, I hope you have a good day too. Thank you.